Today we're going to talk about lesson 5, using matrices to organize data and to solve problems. Matrices are just a way to organize data. What this one says here is use the data in the tables to create two matrices, one for DVD rentals at the Fargo store and one for the Grand Forks store. Then we need to find what F plus GF equals. So a matrix can be written as rows and columns. And if you look at our data here, we already have those set up as rows and columns. So this would be, all we would have to do to put this into a matrix is put the information in to a matrix format here. Each row has something in common, which for this, the top row would be the comedy movies, the middle row is the drama, and the bottom row is all others. The columns also have something in common. As you can see, we have all the movies rented in January and all the movies rented in February. And then to show that this is a matrix, we put these square brackets around the outside of them. Okay, and that's all a matrix is. What we have here, we can say the dimensions of it. We have 1, 2, 3 rows by 1, 2 columns. Alright, so this is what's called a 3 by 2 matrix. And then we have the exact same thing for our Grand Forks store. This is our Fargo store. Here is our Grand Forks store. And we do the exact same thing. We put them into rows by columns. And once again, this is a 3 by 2 because we have 3 rows by 2 columns. All right, not that we need to write that down every single time, but it is important to see that. So there are our two matrices that are created, one for the Fargo store and one for the Grand Forks store. Now it says find Fargo plus Grand Forks, or F plus GF. And all we do for this, the only time that we can add matrices are if the dimensions are exactly the same. Well, since both of these are a 3 by 2 matrix, we can add these two together. And all we do for our first spot is take 1250 plus 985, and we put that in the exact same spot. So that would be 2235. And then we go across, we take the 1340 plus the 1020, we get 2360. We come down to the second row, 1893 plus 1987, and that is, hopefully my math is right, 3880. Our next one, 2455 plus 1765 would be 42. Let's see, 4220, I believe. And then we just add up our other two, as you can see. I'm going to skip that part for now, though. But all you do is we would just add the 2388 plus the 1582 and the 3674 plus 2001. Alright, this is important to see because now between our two stores here, we can see all of the different rentals that we have here. Alright, for each one of the different situations. And that's nice to know because maybe there was something going on. Why did February have way more rentals than January? Why were drama movies more than comedies? And those are important for the business owners to look at to see if they can make more money doing something a little bit different. Alright, now we can do lots of things with matrices. We can find what's called the additive inverse of that matrix. And just like what we talked about in a previous lesson, the additive inverse is our original number plus another number has to equal 0. So the additive inverse, remember all that means for all of these is we just gotta switch the signs. Alright, so 0, negative 4.5, 5, negative 21, negative 1, 1, negative 12, and negative 2.5. And this would be the additive inverse because if we added our two matrices together here, 0 plus 0 is 0. 4.5 plus negative 4.5 is 0. Negative 5 plus 5 is 0, and so on. If we added those two together, every single spot would be a 0 here. Alright? We can also subtract matrices, and you would do the exact same thing. Subtraction, our dimensions have to be exactly the same again. Remember, this would be rows by columns. So this would be 3 rows by 3 columns. This one is the same thing. It is 3 rows by 3 columns. If they are not the same dimensions, you cannot add or subtract them. But since these are the same, we can subtract these. So 2.3 minus negative 2. 2.3 plus 2 is 4.3. Negative 9 minus 0 is negative 9. 1 minus 25 is negative 24. 0 minus negative 6 is 6. Negative 45 minus 10.5, negative 55.5. 17 minus 10, negative 8 minus negative 14, negative 8 plus 14, 7.2 minus 6, and 15 minus 30, negative 15 minus 30 is negative 45. Do remember to put your square brackets around the outsides of this so that we know that this is a matrix. But that's all you're doing, you're just subtracting the elements that are in the exact same spots here. For our next one, it says solve for x here. Yes, we can make this into like an equation where we have to solve for x. Now if you were to solve for x, our first job would be to get x all by itself. So we would think, well, I've got to subtract this over to the other side to be able to solve for x, and that would be right here. We could subtract this matrix, 12, negative 3, over to the other side to be able to solve for x here. And then all we have, negative 7 minus 12 is negative 19. 0 minus negative 3 is a positive 3. And there's our answer. Just like any equation, you can always plug our answer back in for x to be able to see if it fits. So 12 plus negative 19 is negative 7. Negative 3 plus 3 is 0. So this is our correct answer. Down below here, we can solve for A, B, C, and D out of this, but as you notice, we have two matrices set equal to each other, but we have this 2 on the outside. That 2 is called scalar multiplication. So what that means is everything inside of this left matrix here can be multiplied by 2 to equal the right side. So what I would do first is I would take that 2 and multiply it by everything inside the matrix. So we'd have 2a plus 2, 28, 2c, and 2d. And that equals the right side. And then from here, it's just kind of a puzzle. What can we solve for? Alright, and we're not going to be able to solve for all of them at the exact same time. It depends on what we're given. If you look at our upper left-hand corner, we have 2a plus 2 equals 5. Since we only have one variable in there, we can absolutely solve for a here. So we'd subtract the 2 over, We get 3 divided by 2, a equals 3/2. So there's one of our answers. Then if you look at the upper right-hand corner, they tell us b equals 28. Sometimes you don't even have to do anything to solve these. Our next one, we're going to bring it over here. We've got 2c equals b minus 2. Now, this is where you would have to solve for one of these variables first, because we've got two variables in the equation, but this b equals 28, we can throw that right in there with our substitution, and then solve here. So 2c equals 26, so c has to equal 13 when we divide by 2 there. And now that we have all of that, we can solve for our last one here. We've got 2d equals 0.5 ab. Well, 2d equals 0.5 times 3/2 times 28. If you multiply these three numbers together, we would get, let's see, 28 divided by 2 is 14, divided by 2 is 7, 7 times 3 is 21, equals 2d. So d would have to equal 10.5. And there's our fourth answer. So we solve for all three of them. We don't have to put them in any special order or anything. We just got to put our answers down and solve the question that is being asked. All right, and that is it for matrices. This assignment is not your assignment anymore. It is on PowerSchool. If you have any questions at all, please let me know.